MusiKraken is a MIDI controller app with which you can use all kinds of sensors built into your smartphone or tablet to make music. The sensors and the MIDI effects can be combined in all kinds of ways so that you can completely adjust the MIDI controller to your needs. Mobile devices have many sensors, and MusiKraken supports most of them, but it depends on the capabilities of your device. So not all of the following input modules might be available on your device. Smartphones or tablets usually have a camera that can be used to track things in front of it. MusiKraken allows you to track your hands, your body, your face, colored objects, barcodes, and cats and dogs. Your device also has a multi-touch screen. This allows tracking the position of multiple fingers simultaneously, and some devices also measure the radius or pressure of your fingers. With MusiKraken, you can use this to control multiple parameters simultaneously while sliding on the keys and changing the radius or pressure of your touch. The keyboard in MusiKraken also supports MIDI polyphonic expression, also known as MPE, which allows you to control the pitch or other parameters independently per note. And it is one of the first products worldwide to also support MIDI 2.0 per note controls. The keyboard is also completely configurable. You can select from different layout types, highlight scales, or hide non-scale notes to make playing in key easier. There is even a setting to switch to left-handed mode. The chords pad has one key for each chord in the selected scale, and below are keys for their inversions. And you can also control parameters while sliding on the keys and using the touch radius or touch pressure. When using the touchpad, you can use the average position of all your fingers or the distance between the fingers to control the sound. It is nice to combine this with a MIDI keyboard so that one hand plays the notes and the other one controls the expression of the sounds on the touchpad. On iPads, you can also use an Apple Pencil on the touchpad to control the sounds with pressure and tilt. There are also separate button and slider modules. Then there are the sensors that measure the orientation and motion of your device. The motion sensor module combines the accelerometer, gyroscope, and magnetometer to measure the current orientation of the device in 3 dimensions. This allows you to control sounds while rotating the device or trigger notes when the device is held in specific orientations. You can, for example, create a setup that uses the current rotation around you from the compass to define the pitch of a note and trigger that note when the device is rotated downwards. But that is just one of the many possible use cases for this. There is also a separate accelerometer module, which measures the current acceleration of the device, so you can make music while shaking the phone. And there is a separate magnetometer module so that you can use magnets as input. You can also use the microphone to detect the current pitch and amplitude of a sound and convert these to MIDI. MusiKraken also supports external devices that can be connected to your device. For example, you can connect game controllers and use these to make music. Every button, thumbstick, or touchpad can be independently assigned. On the PlayStation 4 and 5 controllers, you can even assign separate colors to each button to control the lights. And you can trigger the haptics of the controllers. MusiKraken also can get the input of connected computer keyboards and mice. The keyboard keys and mouse buttons can be assigned to trigger all kinds of MIDI events, and the mouse movements can be used to control various parameters. On iPhones, MusiKraken also supports Apple Watches. You can use the motion sensors of the watch or control the sounds with touch, the digital crown, or with the measurements of your heartbeat. And some AirPods also have motion sensors. You can even use these to make music. While the sensors act as the inputs for your MIDI controller, MusiKraken also has various effects and output options. By combining the input modules with the effect modules and sending the result to the outputs, you can create all kinds of MIDI controller combinations. To understand the basic idea behind MusiKraken, let's have a quick look at how a typical MIDI keyboard controller works. A MIDI keyboard has multiple keys. If you press a key, it will play a note. But it is not the key itself that makes the sound. The key simply contains one or more sensors that react to pressure or sometimes touch. The typical keyboard key sensor measures if the key has been pressed down enough and also the velocity with which you press the key downwards. There are often other sensors on the MIDI keyboard, like the modulation wheel or the pitch bend control. So there needs to be something that converts the measured sensor values to notes or other MIDI events. Internally, the keyboard will react to the sensor measurements and decide that a key was pressed and with which velocity. Now it should play a note, but which one? There are 128 possible note values in MIDI, so the keyboard would need to be very large. To make it smaller, there usually are buttons to select the octave on the MIDI keyboard. The keyboard now, for example, knows that the second lowest key was pressed and that currently the fifth octave is selected. It knows that the second lowest key is a D and then transposes this D to the fifth octave. And then this note information is sent out through the connected MIDI or USB cable or via Bluetooth or Wi-Fi to a computer or synthesizer that will generate the sound for that note. In MusiKraken, this works similarly. The sensor inputs generate values, which are then converted to notes or other MIDI events. The generated MIDI events can then be sent through effect modules, like the transposer module, which also transposes any incoming note values to another octave. And then the resulting MIDI events can be sent to output modules that will transport the events to another app or another computer via Bluetooth, Wi-Fi, or USB cable. If you start MusiKraken, then change to the editor screen and press on the plus sign, you will see this exact separation: input, output, and effect. Using these building blocks, you can construct your own personal MIDI controller. MusiKraken is a MIDI controller, so most modules send the MIDI events either to another app running on your device or to a computer that has a synthesizer or any other music production software. MusiKraken supports all kinds of MIDI transport options. You can send MIDI events via Bluetooth or Wi-Fi to other devices, and some device combinations also allow sending via USB cable. You can also send the MIDI events to other apps on your device, and on iOS, the app acts as an audio unit host, so it can host plugins directly in the app. MusiKraken can also send the raw data of the sensors via Open Sound Control, also called OSC. And it even was one of the first products to support Network MIDI 2.0. The Simple Synth is a very simple synthesizer that was added to the app for simple tests. On iPhones, there is even a module that lets you control the haptics of the device. If you send MIDI events to it, the phone will start vibrating, and the strength of the vibration can be controlled with Control Change 1. MusiKraken has two screens. When you start the app, you will see the main screen where you interact with the sensors and make music. If you tap on the arrow button, it will move to the editor screen, where you can combine the modules and create your own MIDI controller setup. Let us start a completely new project. If you tap on the folder icon, it will open a menu where you can load, save, or share your projects. Now select the new project option. You now have a completely empty editor screen and therefore also an empty main screen. To create a new module, tap on the plus sign. Here you can switch between input, output, and effect modules. To create a MIDI controller, you at least need an input and an output module and connect these. So for a simple example, let's create a keyboard module. Select the keyboard and tap on Create. In the editor screen, you can zoom with two fingers. You can move around by pressing outside the nodes or move nodes. So let's zoom out and make room for our output module on the right. Again, press the plus sign and select Output. For this demonstration, we will create a Simple Synth module because that is guaranteed to be available on your device. The Simple Synth is very simple and only used for testing, so don't expect a great sounding synthesizer. Once you understand the basics, please use any of the other outputs instead. So select it and tap on the Create button. Now you should see both the keyboard and the synthesizer module in the editor. To connect them, simply press on the orange MIDI out port of the keyboard, move your finger over to the orange MIDI in port of the Simple Synth, and release. This is similar to when you connect a MIDI keyboard to a computer. All the orange ports are MIDI ports, so connecting them is like connecting a MIDI cable. If you now go back to the main screen, you should see a keyboard, and when you press a key, you should hear a sound. So let us go back to the editor screen. On the nodes, there is often a cogwheel. Tapping on these will show you the options for a module. For example, if you open the settings for the keyboard, you can change the layout type, how the velocity of key presses should be simulated, highlight or restrict to scale notes, and activate MIDI polyphonic expression, plus many other settings. If you tap on a node, you select it. A side menu will open on the right, where you can delete or clone a node. You can also tap on the connection lines. Then you will see options for this connection. For MIDI connections, there is only the option to delete them, but there are other connection types as well, as we will see soon. The input ports are on the left of a node, and on the right side are the output ports. The orange MIDI ports send out all kinds of MIDI events, so in the case of the keyboard, it will send MIDI note events, so a note-on event if a key is pressed, and a note-off event when a key is released. But there are also the green ports. The green ports are value ports. They send out numerical values. The keyboard, for example, has a green X slide and Y slide port, and a radius, and for some devices, also a pressure port. Most input modules have green ports, and they usually send out the measurements of the sensors. So for example, the hand tracking module has green ports for the positions, the hand openness, rotation, and tilt. The green ports send out numbers, but in the end, we need MIDI events to make music. So there needs to be a way to convert the numbers to MIDI. For this, there is a separate module called the value to MIDI converter. The easiest way to create one is to simply connect a green output port with an orange input port. If you connect the Y slide port of the keyboard with the MIDI in port of the synthesizer, it will automatically create a new value to MIDI converter in between. You can also create a value to MIDI converter in the effects menu, but connecting the ports is easier. Now the numbers sent out from the green value port will be converted to MIDI, which can be used to control the music. If you open up the settings of the value to MIDI converter, you can select what kind of MIDI event the numbers should be converted to. By default, this is set to control change with the target controller 1, which is the same as it sends if you manipulate the modulation wheel on a physical MIDI keyboard. To better understand these settings, let's have a quick overview of the MIDI channel voice message types. If you press a key on a keyboard, it will send a note-on event, and if you release the key again, it will send a note-off event. This way, the receiving instrument knows which note and how long it should be played. The note events also have a value for the channel, a number for which note should be played, and the velocity, which is typically how fast the key was pressed down. Then there is the control change event. This is, for example, sent when you turn the modulation wheel. Modulation is CC1, but there are other important control change parameters like volume on CC7 or expression on CC11. Pitch bend events are sent out when you turn the pitch bend wheel on your keyboard. As the name says, this bends the pitch of the current sound. And then there are two different pressure events. The channel pressure sends one single pressure value for the whole channel, and the polyphonic aftertouch sends a different pressure value per note. The polyphonic aftertouch is a bit of a special case here, because it needs to know on which note the value was created. So in MusiKraken, this currently only sends events if it is connected to one of the keyboard ports or the pressure port of the ghost organ. But then you can generate different polyphonic aftertouch events per note. If you go to the main settings of the app and enable MIDI 2.0 support, you also get the option to generate per note MIDI 2.0 events. Same as polyphonic aftertouch, these only work with the keyboard or the ghost organ. MusiKraken is designed to be completely modular. To achieve this, the range of each value port is converted to an output range between 0 and 1. This way, everything can be independently connected. So for example, the values the motion sensor generates are all between -1 and 1. If I, for example, rotate the device downwards, the pitch port will send a negative value. And if I rotate it upwards, the pitch will be a positive value. Now the connection from the green pitch port to the value to MIDI converter will convert this range to a range between 0 and 1. So every output of every sensor will be converted to a range between 0 and 1 by the connection between two green ports, no matter which sensor it is. This makes it completely modular. It doesn't matter if you control a parameter with your hands, your face, a game controller, or anything else. The output will always be in the same range between 0 and 1. You can change how this conversion works by selecting the connecting line and tapping on the cog wheel in the side menu. So if you, for example, want to ignore all downward movements of the motion sensor, you can change that here, or you can invert the range so that, for example, downwards movements will increase the value. And you can also change the curve of how the sensor value should be converted to the output value. To demonstrate this, let us create a simple theremin. First, tap on the arrow sign to change to the editor screen. Now tap the sign that looks like a folder and select New Project. This will create a new empty project. Then tap on the plus sign and create a hand tracking module. To make music, we also need one of the output modules. So tap the plus sign again and select Output in the top row. This output module list is a bit different depending on the capabilities of your device. So let us use something that should be available on all devices, the simple synth. Now put your finger down on the distance port of the hand tracking module and move it over to the MIDI in port of the synthesizer. This will automatically create a value to MIDI converter in between. By default, the converter is set to convert to modulation, but in our case, we want it to generate notes. So tap on the cog wheel and change the type to note. Now, if you go back to the main screen, you should be able to control the note by moving your hand closer or away from your camera. The distance port uses the size of your hand on the camera image to measure the distance. But if you have an iPhone or iPad Pro with a true depth sensor, it will use the real measured distance instead to make this more accurate. To make playing easier, let us go back to the settings. In scale type, you can, for example, select a predefined scale so that each generated note will be a note of that scale. There are a lot of scales to select from. Additionally, you could change that it generates chords instead of single notes here. To get the real theremin feeling, also enable legato here, which will make the notes overlap each other a bit, and then go to the settings of the synthesizer and enable mono mode. This will make the sound glide between the notes. So now you have a simple theremin. To make it a bit more interesting, you can also connect the open output port of the hand tracking module with the MIDI in port of the synthesizer. Now, how open your hand is will control the modulation of the sound. But this isn't ideal in this case. If I open my hand, it should have less vibrato, not more. We can fix this. In the editor, select the connecting line going out of the open port. Tap on the cog wheel in the side menu and enable inverted input range. This will invert the range so that the open hand is now 0 and the closed hand is 1. Maybe also adjust the input range to only start vibrato once the hand is closed enough. Now you can start the vibrato by closing the hand and stop it by opening the hand again. The special thing about MusiKraken is that you can use any sensor output to control the note or the modulation, not just the hand distance. Simply connect any other output port. So you can, for example, create a face tracking module and control the note with your mouth. Or create a touchpad and control the note by sliding your fingers along its surface. Or you could even control the note by sliding on the keys of the keyboard. The value to MIDI converter simply doesn't care who sends the incoming value. It just processes these values and generates MIDI events in a completely modular way. Now let us build a setup to give you ideas of what you could build with MusiKraken. We will create a unique MIDI controller that combines the motion sensor input module with a threshold effects module. With it, you can start playing a note by pointing the phone downwards and stop the note again by rotating back again. The notes are arranged around you using the compass information. First, delete everything, either by creating a new project or by simply tapping on each module and deleting it. Now create a motion sensor module. Tap on the plus sign and with input selected, scroll down until you see the motion sensor. Select it and tap on Create. In the editor, you can see that you have created a new motion sensor node. If you go back to the main screen, you should see a small area in the top row that shows the current device rotation with roll, pitch, and yaw. If you rotate your device, these values should change. Back in the editor screen, move the motion sensor module to the left to make room for the rest of the setup. Now let us create an output module so that we can hear something. Tap on the plus sign again and select Output. Here you can see a list of all output modules that your device supports. In this example, I will connect my phone to my Mac via Wi-Fi and send MIDI to it. The MIDI will then go into Logic Pro, which will generate the sounds. Tap on the plus sign, go to Output, and either create a core MIDI network module on iOS or a MIDI over network module on Android. The reason why these are called differently is that on iOS, there is an official network MIDI implementation by Apple that can be reused and that is shared between apps. But on Android, there is no such thing, so I needed to create my own implementation of network MIDI. For the few users that already use MIDI 2.0, if you enable support MIDI 2.0 in the settings, then you can also create a network MIDI 2.0 module on both iOS and Android. This way, you can send MIDI 2.0 events on your local network, but only if the receiving device also supports it. So let's keep to the MIDI 1.0 version in this example. If you do not have a computer with Wi-Fi MIDI support, you can also use anything else here. For example, the simple synth. To connect to your computer, tap the plus sign on the bottom of the network MIDI node and select the computer from the list. On the left side of a node are the input ports, and on the right side are the output ports. So it makes sense to align the nodes so that the MIDI flows from left to right. To connect two ports, simply drag from one port, move to the second one, and release. When connecting the pitch output port with the MIDI in port of the output module, it will automatically create a value to MIDI converter because it is a connection from a green output port to an orange MIDI input port. If we change the converter so that it generates notes, it should send the MIDI events to the computer and generate sounds. If it doesn't, then make sure you actually have some sound generator software running on your computer, that the software receives the MIDI events, and that your speakers are enabled. There are all kinds of reasons why this might fail, so we are not going into the details here. Our MIDI controller is currently similar to the theremin setup from before. You can simply control the pitch of the note by rotating your phone up and down, which is not what we want here, so let us delete the value to MIDI converter for now. Instead, we will create a threshold module. Tap on the plus sign, select Effects, and create a threshold module. To make the threshold work, we at least need to connect the value input port and the MIDI output port. Connect the pitch port of the motion sensor module with the value input port, and connect the MIDI out port with the MIDI in port of your output module. What the threshold module does is that it reacts to the value sent into the value port, and if the value is lower or higher than a specific threshold, it will send a MIDI event out of its output, for example, a note on event. And if the value goes back again, it will trigger another MIDI event, for example, a note off event, to stop the note again. By default, it will start playing the note C when the value goes under the threshold and stop the note again when it goes back, which is what we want in this case, but you can change that in the settings of the threshold module. If you now rotate the device downwards, it will play the note, and if you rotate up again, it will stop the note. Currently, this will always be the same note, but there is a setting for this as well. If you tap the cogwheel again, you see the settings for the action. Here you can set it to trigger all kinds of MIDI events, but what we want in this case is the notes from input port setting. What this does is the following. There is a notes input port on the threshold module. If you connect anything to this and send note MIDI events to this, the threshold module detects which notes are active and copy exactly these notes at the time when the threshold is triggered. This could be single notes or full chords. This way, we can not only use one sensor to trigger the notes, but we can use another sensor to define which notes are being triggered. Here we use the yaw value of the motion sensor to generate the notes. The yaw value is basically the compass value, the rotation around you. Connect the yaw port to the notes input port. This will automatically create a value to MIDI converter. Set this to generate notes. Now you can play different notes. The notes are distributed evenly around you, so depending on the yaw of the phone, it will play a different note. As long as the note is active, it will not change even if we change the incoming MIDI notes. Only if we go back can we play a different note. It currently generates all notes in the range. To make this easier, let us restrict to the notes of a specific scale. Go to the settings of the value to MIDI converter and change the scale type to predefined scale. Now select one of the many scales. Maybe we should leave it at C major in this example. All notes that are being played are now notes of the C major scale. We can now play melodies in the air. The placement of each note is surprisingly precise because of the compass. There is also a reset button on the motion sensor panel. Point the phone in the direction you want the middle note of your selected note range to be, and rotate it at the angle where the note should start, and then tap on the reset button. This way you can control how the notes are laid out. The threshold module also has an intensity output port. This output value increases the more your input value is away from the threshold once it is activated. So in this case, the farther down we tilt the phone, the higher this value is. We can use this to control modulation. Connect the intensity port with the MIDI in port of your output module. By default, the new value to MIDI converter has modulation selected, which is exactly what we want here. Now, if you play a note, you can tilt the phone even further to increase the modulation. So now we can play notes in the air and control its modulation by rotating the phone even further. To make this even more interesting, we can also add pitch bending to this MIDI controller. The threshold module also has a side value input port. This works like this. At the moment when the threshold starts the note, the value from the side value port is stored. This stored value is now taken as a reference, and the difference to new incoming values are computed and sent out of the side intensity output port. The side value input port and the side intensity output ports belong together. The side intensity is computed on how much the side value deviates from its starting value. To demonstrate why it works like this, let us connect the yaw port of the motion sensor to the side value input port, and then connect the side intensity output port with the MIDI in port of your output module, and select pitch bend in the created value to MIDI converter. Now, the MIDI controller still plays notes when you rotate it downwards and controls the modulation the further downwards you rotate it. But as soon as the note starts, the current yaw rotation is stored and will be the side intensity with value 0. If you now rotate it to the left, the side intensity value will go down. And if you rotate it to the right, the side intensity will go up. So now you can also control the pitch bend. This is how you build your MIDI controllers in MusiKraken. Simply add one feature after another and test it to see if it improves what you want to do. And everything is completely modular. You could, for example, replace the motion sensor module with a hand tracking module. For example, use the hand rotation value to trigger the notes, and use the X position of your hand to define which note is being played. Or use your face rotation to define the note and trigger it by opening your mouth. There are so many combination possibilities. On iPhones, we could even add haptics to our new MIDI controller. Tap on the plus sign, go to Output, and create a haptic module. And then connect the MIDI out port of the threshold module and the MIDI out port that sends modulation values to it. The incoming notes will start and stop the vibration, and modulation will control the strength of the vibration. If you want to keep a MIDI controller setup, you can tap on the folder icon and select Save. Give the project a useful name and tap on the Save button. There is also a button that lets you add project notes so that you can describe what your MIDI controller does. The project notes will then be shown when loading a project. Now that you know the basics of how to create a new MIDI controller setup, it is time to quickly go through some of the available effect modules. The chord splitter splits incoming chords into separate notes, sorts these notes by pitch, and sends each note to a separate channel. This way you can play multiple legato or mono instruments simultaneously and even get per note control when combining this with the keyboard module. The arpeggiator steps through the notes of incoming chords in a predefined pattern. You already know the value to MIDI converter, which is used to convert the numeric values from sensors to MIDI events. But there is also the opposite, the MIDI to value converter. With this, you can convert MIDI events from external MIDI controllers to the internal value system, and then map these values to new MIDI events. So you can, for example, control modulation using the keys of your keyboard, or play notes with your pitch bend wheel. As explained in the example before, The threshold module plays a note when a value goes above or below a specific threshold and stops the note again when the value goes back. You can combine this with another input to define which notes should be played. The beat module is similar, but instead triggers notes when the input value changes fast enough. The distance module measures the distance between 2 points in space, which is mostly useful for camera tracking, where you, for example, can use the distance between both of your hands or between a hand and a colored ball as a new control parameter. The filter lets you filter MIDI events by note range, channel, velocity, or control change ranges. This way you can, for example, split your keyboard into separate parts or play different instruments depending on how hard you hit the keys. The speed module computes a new value based on how fast the incoming value changes. The faster you move, the higher the new value is. The gate module only passes on incoming MIDI events if at least one note is active on its gate input port. This makes it possible to, for example, only play notes if your hand is open, but stop playing notes once your hand is closed. The particles module plays many short notes randomly distributed on all incoming notes. You can control how many of these note particles should be generated per second and how random the rhythm should be. There is also a randomizer module that randomly changes the note, velocity, or control change values of incoming MIDI events. And then there is the channel switcher. It allows you to assign MIDI events to a different MIDI channel. This is especially useful if you have multiple instruments active on different channels. The velocity replacer allows you to replace the velocity of MIDI note events. With this, you can use the input of any sensor to control the velocities of notes. The transposer lets you transpose incoming MIDI notes to a different octave or by semitones. The transposer has input ports to dynamically change the transposition. This, for example, lets you play the ghost organ on different octaves by dynamically controlling the transposition with the distance of your hands. The scale quantizer makes sure that all notes are of a specific scale. Non-scale notes are changed to the closest note belonging to the selected scale. The minimum-maximum module lets you combine multiple values so that only the maximum or minimum of the incoming values is passed on. The latch module keeps notes alive after they are stopped until you start the same note again. The value smoother smooths values with strong fluctuations to reduce noise. For example, the output of the microphone amplitude port reacts strongly to small changes. With the value smoother, you can control how fast this value reacts to changes. The LFO module is a low-frequency oscillator that generates sine waves and sends these out of the value port. And the envelope reacts to when you start or stop a note and automatically creates curves for these. The Boolean logic module allows you to apply Boolean operators to MIDI note events. You can set the Boolean operator to, for example, only trigger if there is a note active on both input ports. This lets you create very complex combinations. And the pass-through module simply passes on incoming MIDI events without doing anything else. It can be used to make grouping MIDI connections easier. This way you can, for example, replace the output by a different one later without having to reconnect everything. By combining the input modules with the effects modules and sending the final MIDI events throughout the output modules, you can create all kinds of combinations. The possibilities are endless. I hope this overview helps you to get started using MusiKraken. You should now understand the basics of how the app works and give you some ideas of what you can do with it. And I hope you will have as much fun using MusiKraken as I have.